Okay, good morning all. Welcome to another Martin Audio webinar training. And today we are going to be covering display 2.3.3. So this is going to be an overview of the display software with some added features in the 0.3 revision. So my name is Ben Tucker. I'm an audio product support engineer. So I kind of help write this training, do system designs for a lot of our customers and sales staff. As well as deliver the training, I should mention, and help anyone out with any technical inquiries they may have. I'm also joined today by my colleague Simon, who is here on hand to answer any questions you've got throughout the presentation. And there will be a little Q&A at the end where you can dive in and ask me or Si anything you may have regarding display or indeed anything else in the Martin Audio world. So, display 2.3.3, first of all, is free to download from the Martin Audio website. It is the proprietary software for designing systems with wavefront precision, MLA, and optimized O-line. It features a patented approach using extremely accurate computer models of the arrays to analyze the system performance in a detailed venue drawing to calculate precisely parameters for the system in order to get a defined coverage. So the idea behind this is it is optimization software, more than being a piece of simulation software. It's more aimed at being a tool for you to get a preset out of your array to get a system up and running nice and quickly. So there are two UI modes within display. There's a basic and expert. 90% and even more so now with the new features in display 2.3.3. Of users will come across basic. We're going to go through that today. The expert mode does open up a few more features for advanced users, and mostly these things are aimed more at MLA rather than WP. But you can easily change it by going into the Help Preferences menu and selecting the UI mode. So I've already mentioned, and a big part of the process is discussing how display is a tool rather than a piece of prediction software. So what you do is you input in your venue data, sound design objectives. You choose your array, type in size, draw a venue slice. So we're working in 2D here. Define the audience criteria, mechanically optimize the array. You'll then get some information on the array, optimize it numerically, and then we can export the preset to load into MLA itself or into our icon amplifiers for WP. You can also export some ease data, 3D wireframe drawings, and some mechanical data, all of which we'll look at later on. So firstly, when you open the software for the very first time, you'll be prompted with this little dashboard screen. What you want to do is type in unlock D2 to load into the software. The password is not case sensitive. And then you'll see the series of videos throughout the presentation, which will show you how we go about designing a system with display. So first of all, you choose your array type, decide how you want to deploy it. So we can fly it with subs, we can ground stack it, and in the smaller arrays, we can pole mount. Choose your total number of cabs per array, give it a name, and click add. Now we're going to come to the first part of the software, which is our slice. And here we're going to create the venue geometry, add an audience area, and add the array we've just defined. So first of all, simply click on the little button along the top to open up a window. And here we can define our maximum working height and length. Make this large enough to fit the geometry, and we don't need to worry about exact dimensions because we can adjust this at a later stage. It's also worth mentioning that we can load in a pre-drawn room from that screen as well. And now, one of the big parts is drawing the room. So I can't stress this enough. Roughly draw your room, always working anti-clockwise. So this will draw the room with it the right way around. So the surfaces we're seeing being drawn there are on the inside, not the outside. And you can right click or double left click on the final point to close the shell. Don't worry if we've added too many points or do not have enough. These can be added after, which we'll go through how to do. So now we can define the points in the table. So the X column is working horizontally and the Z column is working vertically. And we can use the tab key on our keyboard to quickly cycle through the vertices. So you'll see that the numbers down the side correspond with the numbers drawn in the shell. So as well as doing it this way, there's also what we call the survey mode. And this allows us to use the angle and distance measurements from a single point within our venue. So on most laser measures, there is a mode that will allow you to calculate the distance and angle, and we can type that in with reference to the yellow diamond there. And this will work out the calculations required to get the points you need. There's also a vertical offset, which allows for measurements to be taken off the ground with a laser measure fitted to a tripod, for example. In here as well, we also have some view parameters, so we can expand the view both horizontally and vertically, and we can also snap the view to the size of our working shell. We can now simply place the array. Again, anything drawn at this stage can be done roughly, and there is fine-tune adjustment in the array position dialog. So it's worth noting as well that the array height is measured from the top of the first cabinet in the array. So even if you're flying an array with subwoofers, it will be taken from the top array cabinet, not the top of the subwoofer or the top of the grid. And there's the little button in the array position, which allows you to select on ground. So for ground stack systems, this will lock the bottom of the array to the ground plane below it. Again, the height will be locked out and it will be defined from the top of the array at this stage. Finally, within this window, we need to add an audience area. So we click on the add audience, select our audience start point and drag it through the shell, working again anti-clockwise to our finish point. And what you can also do here is move our audience start point, our audience finish point, or we can remove the audience and redraw it if we need to. So now we're going to move on to the cover. So here we're going to define audience coverage, non-audience areas, SPL at reference point, and the relative positions at that point. So first of all, we need to know where the audience ear height is. So by default, it's set to standing, which is 1.6 meters from the plane, and seated uses 1.2 meters. So we can do a mixture by unselecting uniform offset, clicking on the line we wish to change, and this will allow us to have both standing seating, or there is also a custom offset which can be applied to any audience region. So as well as audience heights, there's also line properties. So in order to achieve a desired array preset, we need to consider our array properties. So we have three types: our audience area, which we've already defined, our non-audience, which is shown in red here, and our hard avoid. So to achieve the desired properties, we simply click on the property type on the column on the right, and then select the line in which we wish to apply it to. So by default, the hard avoid is placed between points 1 and 2, which is commonly our stage. Any other area that wasn't defined as an audience will appear in red and be a non-audience. So we can have multiple hard avoids in a slice, although this isn't recommended. We try to keep our hard avoid small and close together to give the array the best output for all three sections. So of course, if we're trying to make a whole room with hard avoid and just an audience area, we're going to sacrifice some consistency throughout our audience. Now, in a room with balconies, you can see that where we draw our audience area, every line between has been defined as an audience. So we just need to go through and make sure that these lines under balcony and along the back wall are being changed to non-audience. And you can see there under balcony is shown in pink, not red, and this is not included in the optimization as the array does not have line of sight to it. And now we come to a really powerful feature in the cover page and possibly the most powerful feature in display. And this is the SPL profile. So what this allows us to do is pick a reference point anywhere in an audience. A lot of people commonly use the front of house position for this. And what we can do here is tell our array how much we want the SPL to increase and decrease around this pivotal point. So if we look at that in another form now, here we have the default wavefront precision SPL profile with our yellow triangle denoted there by the line and the reference position. And we are smoothly increasing 4 dB towards the audience start and decreasing 4 dB towards the back. Now, by changing these deltas, we can start to shape the profile of our SPL throughout the menu. So we can see there now, it's now increasing less towards the front of the audience, but decreasing more. So things to really consider here are how long your line is, how far your audience throw is, and something we'll get into a little later on is how much resolution your system has, because all of these will have an effect on how well you can shape your profile. And indeed, how your SPL profile is shaped is going to have an effect on how well your optimization is working with these factors. In some cases, you can do some pretty extreme things. Here we have a 13 dB variation with 5 dB variation within the first 8 meters, and then dropping off by 8 dB towards the back. So it's all things you can play with and really understand and learn to understand how the SPL profile can have a big effect on the output of your array. So now we're going to move on to display, where we're going to optimize the array mechanically. So display now takes over the optimization process. So simply in this page, all we need to do is click optimize, and we'll see now the array doing a little dance and working out the best acoustic angles of every cabinet within the array to achieve the best acoustic output before we've applied any EQ. You can also change the overall aim of the array here, the height of the array, the horizontal position, and the box quantity as well. You can also manually override any inter-cabinet angles if you so desire. We do always recommend, however, that first you optimize it and get your system running as the software is intended to. And then if you're unhappy, you can go back and start to change things. So once we have optimized, we can go in and have a look at some of the mechanical data. So here we can see things like the inter-cabinet angles, the array height. There's a lower trim as well that can be measured. We have mounting options for most systems, so whether we're flying with subs or without, with touring or install bars or 1 or 2 point lifts. We can change all those options in this page. Now you guys probably saw that video happening then. The most common thing is when we're changing from a 2 point to a 1 point lift, the design aim may need to change ever so slightly to accommodate the nearest hole, and display will update in real time and tell you that. At this point as well, it's I always recommend snapping a photo of this page or a screen grab. So as you're working on the electronic optimization, arrays can start to be put up in the air. So you have all the information you need from here. So now we're going to look at optimizing the array numerically. So we talk about WP with scalable resolution, and what does that mean? So resolution is decided by the number of boxes to amp channels. So we can see here WPC in 3 forms. First of all, with all 3 boxes receiving the same signal. And then we can split the 4 boxes up in the middle. So the top 2 boxes are receiving the same signal, and the bottom 2 boxes are receiving an entirely different signal. And display will account for this and give you all the preset that you need to achieve that. And finally, obviously, the optimum solution is the 1-box resolution, whereby every box in the array has its own signal and set of coefficients to it. Now, of course, this scalable resolution only applies to wavefront precision, as MLA is a completely fully optimized solution, with MLA having 6 channels of amplification DSP per cabinet and MLA compact having 5. So the nice thing about WP is the fact that it is scalable, and we can make our decisions based on how many amp channels we have available, and if we're in a touring market, of course, how much budget there is in the event to send out amplifiers. So the advantages of this, first of all, we're going to have a look at a standard array with no optimization in it. And we can see there that there's a large variance in SPL between the 3 audience points, and there's not a great deal of rejection behind the array. Now we're going to start to add some optimization. So here we're looking at a WPM array, 8 boxes. First of all, with 4-box resolution. So the top half of the array and the bottom half have independent signals respectively. And we're already starting to see some more consistency in SPL and a more linear frequency response across the audience. As well, we're starting to get a bit of re-rejection. So the blue is defined as a hard avoid in our coverage page here. And we can see it starting to work even at 4-box resolution. Now, if we double that to 2-box resolution, we of course expect to see even tighter consistency in the SPL and frequency response, and some further rejection. So 2-box resolution is probably the most common scenario we're going to see. Most other manufacturers tend to kind of specify 2 boxes per amp channel with their touring systems, and we've kind of set the benchmark here at 2-box resolution. So even with the same amount of infrastructure, you're getting a better result, or more consistent result rather, by doing no different other than running through this software. And now 1-box resolution, we can see there's very even frequency response, and the SPL is quite tight throughout the whole audience space, and we've got very good rejection behind the array here. So if we look at the 4 models in the lineup, first of all, we have WPM, which is a passive enclosure, and can be run in anything from 1-box to 4-box resolution, which means we can have up to 16 cabinets run on a single IK42 amplifier, or 32 cabinets on a AT1. Excuse me. Now moving up, we can have a look at WPS. The WPS is again a passive enclosure and can be run in 1 to 3-box resolution, so we can maximize 12 cabinets per 42 here. Moving up to the bigger brother again, it's WPC, which is a bi-amp enclosure. Again, it can be 1 to 3-box resolution, so of course double the amp channels per cabinet, half the available amp channels per amplifier, so we're limited to 6. And then WPL is the big boy in the range. This can be optimized in either 1-box or 2-box resolution. And the reason we do this is to keep the cell height in the HF close enough together so we're not starting to get breakup between them receiving the same signals in 3 boxes in an array. So we can limit ourselves to 4 cabinets per amplifier here. So going back to display, we'll look at how to do this. Simply select our resolution by clicking the less and more buttons, and the graphic there will update to show what is going on. In addition to that, we also have some environmental factors, so temperature, humidity, and pressure, which especially when you're working out outdoors or in cold countries, or indeed hot countries, it's a good idea to kind of monitor this and keep your optimizations updated, because this can have a big effect on the array, especially in the HF. As we know, differences in temperature, different speed of sound, it's going to have an overall effect on the array, let alone an optimized one. And we did see there, whilst I was rambling on, the graph at the bottom there shows all of those green dots we saw earlier on in our cover page, and they all started to converge at one another as the optimization is working. So this is it at 2 box resolution, and we can see there that they've all tightened up right the way through the frequency band. So we're nearing the end, amazingly. This has become a really, really short webinar, somehow. So first of all, now we just want to check our results. So what we're seeing here is the frequency response graph. We're looking at between 50 Hertz to 16K along the x-axis, and SPL up the y-axis. And we can move through the index plot, sorry, and we can see there the response updating in real time and the asterisks in the venue window updating to show us what is happening. So you'll see there the colors changing as well. So the audience is displayed in green, the non-audience in red, and the harder void in blue. And we can work our way all the way around the venue and have a look at exactly what's going on at any one point. I should mention as well, this is a relative response. Of course, we're seeing a fairly flat frequency response across the whole audience area there with just a bit of variation in SPL. That's of course not how we want our system to sound. Display optimizes the array to be flat, and then we apply a voicing curve along with the box tuning to make it sound like a Martin audio line array. So once you're happy with your result, we can export it. So the most common one, of course, is to export to ViewNet. So we select a suitable file location for display to export to, give it a name, and we will see under the arrays column there, any array that is included within our project will appear. And if it is optimized correctly, it'll have an OK on the right-hand side. If not, there'll be a red exclamation mark in our little window to say something is missing or something is wrong. So we should just go through. Or we can uncheck it and just export the arrays we wish to. We can also export a rigging report from display, including all the information that we saw on that rigging page. So to achieve this, you'd click on the printer icon in that dashboard. Again, choose a file location and export. As well, we can also export a 3D wireframe drawing of the array by clicking on the little picture of the wireframe drawing of the array. It's handy that. Again, with all of these exports, you select the file location where you want to put it, and there are some additional options here, whether we want it high detail, whether we wanted to rotate for ease, and have an absolute coordinate position. So I've mentioned ease as well. All the arrays except MLA can be exported as an XGLC file for use in ease. So again, we simply export to a destination and export, and then they can be loaded into ease 4. Unfortunately, our arrays are limited to ease 4.4 because everyone is different, so we cannot have a single licensed file for ease focus for our arrays to work. The export process for MLA is slightly different, and if you need to do that, please do get in touch with us and we can help guide you through that. Now, finally, there's a few little additional things that I wanted to bring up here. If you've made a mistake in one of your tabs and you want to get rid of it, you can simply set, when you have the tab highlighted, rename it as delete, and it will remove that tab from your project. That's a really handy feature that kind of is always omitted, but I wanted to bring it to attention because I use it all the time. And there's also an express mode. Back in the slice page, under the done button, there's a little button that says express, and if we just want to get a quick result on the fly with all of the default settings throughout the system, we can obviously change the resolution here. We can just optimize everything and it will squirt out the DTP file we need to load into our array or into our amplifiers to get the job going as quickly as we can. And finally, if you do get stuck at any time, of course, you can always give any of us here at Mountain Audio, the product support team, a shout to give you a hand with your display projects. Or every little section has a little question mark, which pops up a help window asking you, or telling you rather, what that section is intended to do and what all of the little names and numbers mean. So we've kind of gone through that pretty quickly. I hope you guys have found that all right. But I see that a few questions have been coming through. So what I'm going to do now is just open up the questions window. We'll have a look together. And if you want me to go over anything again, explain anything, I can do. I didn't expect this to be that quick of a webinar. So we're kind of flowed through that very, very quickly. But hopefully that gives you a good insight into how the system is running for display with our optimized solutions. Okay, Pierre, give me a second, and what I'll do quickly is just load up display and we can go through that together. Okay, Pierre, so what we'll do, and for anyone else, we'll just go through a ground stack or pole mount system really quickly, live. So again, first of all, give me two seconds because I keep jumping to another screen. It's wonderful fun. So first of all, we click our array type. So let's have a look at MLA Mini. And we can stack it on its own, or we can stack it on top of subs. Choose our cabinets. So with MLA Mini, we have between 2 and 8 cabinets. With the WP boxes, we have up to 6. Quickly, I'll show you how to import a shell here. So first of all, we go in, we find the shell we wish to load in. If I can remember where I put it. Update. And then we have all of the tabs within our project available to load in. And click import. And now this is going to load up a pre-drawn venue, drawn very roughly by me. So again, the same process works here. If we do want to tidy it up a bit, we can just by tabbing through and changing factors, doing everything we need to there. And then we click on our array. We can see it's really tiny, which is going to look really funny in this big menu. Do the ground stack. Commonly what I do is first of all check on ground. And then, as I mentioned, the harder void will always be placed between points 1 and 2. Now, in this instance, we're going to place a harder void directly below the array. So what I might like to do is add in another point. So we click this new vertex here and just add it in behind the array. And now we can draw our audience area. So I'm not going to fill this whole space because it's going to start to look a bit funky. And we can click done. So moving into cover, there might be a little something extra we'll see here. Yep. So we can see there as well, we have now this zigzagged audience area. So what that means is there are two boxes within that array which are very close to one another in close proximity to the array. So what they're seeing there is one audience point is trying to receive input data from more than one box simultaneously. So what display does is opens up the height of the audience area from a static 1.6 meters to I think it's 1.5 to 1.7. So you have a little more audience height, so the boxes aren't, the array isn't compromised by the height of the audience. So again, we can change the height if we want to seating, which of course it goes away now because the heights aren't being compromised. We can change our profile if we wish. Now MLA, the whole MLA family, has a start and stop delta of +2, -3. And as I mentioned, wavefront precision has a +4, -4. So I'm happy with that. So I'm just going to move forward into display. So the process, no matter if you're flying the array, ground stacking, or indeed pole mounting, is no different. So again, we just go in here and hit optimize, let it do its thing. Now, even though we're ground stacked, the mechanical optimization is always going to work from the top of the array down. So we can see there, all it's done is put a little kick in the bottom of the array. So as I mentioned before, it's good to always just go through, see how the software does, load it in if you have time into your system, have a listen. If you're unhappy, we can go back and start to change things. So I'm hoping, Robert, this also answers your question with the ground stack. So in the instance of MLA Mini and WPM, there are two ground stack bars available. There's a short bar and a long bar. And in the aiming tab down here, we'll have some information relating to that. So the design aim, the nearest aim are still referring to the top of the array. So as with the flown array, when we're flying on one point, we just need to update that to use nearest, and we see it's kicked it up 0.2 degrees. It's told us our bottom angle and our bar angle and the type. So what we're looking at here is we want to use the long bar, and on the bar there will be a numbering that says -16. That'll also be related on the flying frame, so we know that we put the bar in the -16 hole, link it to the bottom cabinet, and we've achieved that bottom angle we need to in order to get this array looking like that. Does that make sense? So again, I mentioned as well, we can remove subs here if we wish to, which will take them away, and now put the frame directly on the ground. We can add them back in as well. So if we are taking subs away, obviously our array height is changed by the amount of the height of the subwoofers, so we'd have to go back in, re-optimize, and come back to this stage. And if we want to change cabinet quantities as well, we can go into the display page and just update here. So maybe we want to add 8, and we'll just re-optimize. So when we're re-optimizing an audience area, I'd always recommend reset. So they're all firing at 0.5, and then just hit optimize again. So again, it's a pretty flat array with a little kick down at the bottom, which we tend to expect with ground stack systems. So we'll go in now, and hopefully So now we're only 0.1 of a degree out, and it wants us to use hole 20 and the long bar. So we see there now the top of the array is overshooting quite considerably. At this stage, I would go against what I said earlier and try and reduce the amount of boxes during this distance or the array height if I can. With MLA Mini, although it is it's a bit trickier to achieve in display, we can grand stack on top of one sub. We just need to work that height out ourselves, remove the subs, and then offset it before we go ahead and optimize. The electronic optimization, however, will try its best to contain the audience area, even with 3 or 4 boxes overshooting there. We can actually just do that now and have a look at how it kicks it down. So I mentioned that MLA families don't have a resolution, so we don't have this resolution tab here. So with MLA family, we just simply hit optimize, and now because the granularity is higher in MLA systems, it does tend to take a bit longer. So do bear with me while this happens. I'll just dive in and check some questions. So we can see the audience areas are beginning to converge on one another, even down at 250 Hertz and below. What we're hoping to see, even though we are overshooting, is the HF where the problems may rise, is they converge quite nicely on one another. We can see as well in the index plot above, it's cleaning up very nicely, containing quite a nice bit of heat throughout the audience area. So the white lines there, we're looking at the audience start and audience finish positions, and the black line is the reference point. So there's a few things that you need to take into consideration when you're running these optimizations. The array type, so I've mentioned that MLA has more granularity, excuse me, so will take longer to optimize. And the speed of your computer as well is going to have an effect on this, as well as the array length, of course, because the more boxes in your array, and the more processing this needs to do. So just got a question there. When using MLA Mini Grand Stack as a side fill, do you mean an on-stage side fill or kind of an infill, outfill system for a main PA? So first of all, with these optimized systems, we are optimizing down to 160 Hertz. So there's group delay and latency involved there. So all of these systems have a latency of 12 milliseconds. Therefore, using them as an on-stage delay, on-stage side fill may not be the best solution. We have had customers in the past and users have no problem using it, especially for more dance type events with DJs and things. As long as there's a delay offset on the headphone out of the DJ mixer, we don't have a problem. However, this could have an effect on stage with live musicians. But if we're talking about using an infill or an outfill system, then it's really looking at how far you want the near field coverage from the ground step system. Will determine how many boxes you have, as well as your array height. And remember that all of these smaller systems, so WPM, MLA Mini, WPS, WPC, and MLA Compact, all have 100 degrees smooth horizontal coverage. So we need to consider that we do have 100 degrees from the array in that respect. So positioning them on the edges of the stage, firing in or out, is normally a good starting point. It's an easy position to time a line back to the main array from there. And just going back to the display slice, we can see up to 10K. I would say we've got a pretty damn good result from the system, given the fact that half the array is overshooting, and we start to break it up. But we can have a look now at the SPL tab and what that actually is doing. So just by dragging through, we can see there that even though we have a lot of boxes overshooting there, it's doing well to keep the SPL down low and increasing up. So even there, we have no boxes firing at that, but the response is pretty consistent. So it shows you the power of these systems. And of course, in the near fields where we've got a big gap between two optimized boxes, and then diving straight into a non-audience is where we start to see a bit of filtering from the system. And we can just have a look on stage as well now at the harder void behind the array, and it's done really well to keep SPL from 500 hertz upwards, or even lower, 400 hertz upwards, down nice and low for the guys on stage, which means we can get more gain before feedback from our kick drum and our low end devices, and indeed any of our vocal mics and things, and it keeps the monitor engineer happy. So yeah, a couple of people have said about older versions of display. We do try and recommend you do update as we release these. These features are here to help you guys design systems and work with the PA. So you may need to refresh your cache on your web browser in order to download them. So Vita, so we can see here up the side, we have the SPL. So we're looking there at, first of all the red is our non-audience area. So we can see we're aiming to be at our reference point at about 95 dB from 400 hertz upwards. And we want to increase roughly 2 dB by that towards the front of the audience, which is doing fairly well. Again, with that filtering in the front, in the near field, and decreasing by 3 dB. Now, of course, the line length is going to have an effect on the low end of the system. So the longer the line, the more control we're going to have on the lower frequencies. If we're talking about the numbers in the index plot, what this is referring to is steps throughout the venue. So we can see at the very bottom of the index plot is the very back of the venue in the blue section. So now if we imagine we unfold the venue, so this point here is to the left, right at the other end is all the way over to the right on a straight line, and these points down the side correspond to the position throughout the venue there, with the course frequency going along the bottom. Does that make sense? Brilliant. Questions seem to have slowed down, so if nobody has anything else, I'm going to wrap this session up. We are rolling out these webinars more and more often. So next week we have Ease Focus next Wednesday with my colleague Robin Dibble. He's going to go through some of our point source boxes and subwoofer deployment in Ease Focus, as well as just an overview of the software and how to get started. So thank you very much for joining. If you do have any questions about this, please do email technical@martin-audio.com. This presentation will be put up online fairly soon, in the next couple of days or so. You'll also be emailed a copy of the presentation materials. I hope this has been a good insight into getting you guys started with Display 2.3 and shows you how powerful the optimized systems can be, how easily it is to get a system up and running. So thank you very much.